Something went wrong in the previous video and it was finished. It stopped unexpectedly, alright, in the recording. So I'll continue from here. So what we have, that is equals 0. So what you have is, when you multiply out the matrices, 9x plus 0y minus 3z equals 0, because this would be 0, 0, 0. Alright. Negative 9x plus 0y plus 3z equals 0. And then 18x plus 0y minus 6z equals 0. Alright. So these would actually be the equations that you would get. But what we want to do is find x, y, and z. What we could do is use the Gaussian elimination method, right? And I was reading something about the name Gaussian. They credited it to Gauss, but it was said that there were literature even before Gauss was born about this method, maybe hundreds or thousands of years before. Alright? Alright, so let's write the augmented matrix. This is 9x plus 0y minus 3z. Remember about the augmented matrix, equals 0, negative 9, 0, 3, 0, 18, 0, negative 6, 0, 18, 0, negative 6, 0. So what we have here is let's put this further up. In fact, I could put it, say, where can I put it? Because we're running out of space. Let's put it somewhere here. Let me see if I can copy and paste it somewhere else. I have this and aha, nice. Where shall I put it now? Let me transfer it up here so we can just work with it alone and don't have the other things in the way to confuse us, right? Alright, so here now, we're going to solve. Let's say now, change, what shall we change now? We want a 0 here, right? So we're going to change row 3 using the Gaussian elimination method. What we're going to do is this. Can get some smaller numbers. Let's change row 1 to row 1 divided by 3 gives us our new row 1. So 9 over 3 is 3, 0 over 3 is 0. Negative 3 over 3 is 1, 0 over 0, 0. Row 2 divided by 3. Let's divide row 2 by 3 to give us our new row 2. So this will be going to be negative 3, 0, 1, 0. And then this one now. Let's just divide by 6. Row 3 divided by 6 to give us our new row 3. So we have 6 3 is 18. 6 into 18 goes 3 times. 0 over 6 is 0. 6 over 6 Negative 6 over 6 is negative 1. 0 over 6 is 0. Alright. So we have these. Alright. So rewriting them in equation form, this is 3x plus 0y plus 1z equals 0. This is negative 3x plus 0y plus 1z equals 0. This is 3x plus 0y minus 1z equals 0. So here, what we have now is this. In this case, 3x is equal to negative z. There is no one specific value for x, y, or z. It's a vector, right? So these are just vectors that have directions. So here, 3x is negative z. In this case, x will be what? Negative z over 3. X is negative z over 3. For this, you would have negative 3x plus z equals 0. So x would be negative z over negative 3, which is the same as positive z over positive 3. And here, x would be, when you work it out, z over 3. So in two cases, you have x is z over 3. So, if you make x equal 3, suppose you make x 3. You can make x be any number, you know. Alright? Alright, let's make x 1 first. X is 1. So it's 1. Y would be 0. And z over 3. Z would be, if x is 1. Oh, make z1, I should say, not x1. Make z1. So it's 1, x would be 1/3. Right? X would be 1/3, I mean. My gosh, I'm confusing myself, you know. Z is 1, x would be 1/3. And you see that y would be 0. There's no movement, no magnitude in the right direction. Alright, now if you multiply everything by 3, make z, if you make z 3, then x is 3 over 3, which is 1. Right? That is one vector. If you look at this and make z 3, x would be negative 1. So this is plus or minus 1. Alright? Negative 1, 0, 3. Alright, so you have two vectors here. So the eigenvalues were what again? They were lambda equal negative 2 in two cases, and then lambda equal 1. Alright? So we got this from lambda equal negative 2. Now, when lambda equal 1, what happens? Let's put it nearer to here. When lambda equal 1, what happens? When lambda equals 1, you're going to have 7 minus 1 is 6. 0, negative 3. Then you have negative 9. Then you have negative 2 minus lambda. lambda is 1. So negative 2 minus 1 is negative 3 and then 3. And then in the third row, you're going to have 18, 0, negative 8 minus lambda. So it's 18, 0, negative 8 minus lambda is negative 8 minus 1 is negative 9. So that's what you would have, all right? So, working with this, suppose you divide, all right, let's use it as it is here. You have 6, 0, negative 3 minus, so it's 6, 0, negative 3, negative 1, negative 3, 3, 18, 0, negative 9, right? So that's what you have, times, just like this one, the xyz, but since we use xyz already, let's say it is x2, y2, z2 equals 0, 0, 0, alright? So what you'll have, 6 by negative 2, by x2, 6x2 plus 0xy minus 3z2 equals 0. And you have negative 1x2, so that's negative x2 minus 3y2 plus 3z2 equals 0. Then you have 18x2 plus 0y2 minus 9z2 equals 0, right? So here you say 6x2 equal to 3z2. Then you have negative x2 minus 3y2 plus 3z equal 3z2 equal negative 3z2. Let's subtract 3z2 from both sides. Then you have 18x2 equals 9z2. Alright, so let's work with these and see what happens. Let me just copy this, move it one side, and combine them, and work on this. Let's put it up here. Alright, so here we can simplify these, making them smaller. Divide by 6, but divide by 3, we have 2x2 is equal to z2. This one remains, negative x2 minus 3y2 equal negative 3z2. But this one, if you divide by 9, we have 2x2 equal z2. So these and these are the same, right? Now, let z2 equal 1. What would be the eigenvectors here? We have 1. Now, z2 equal 1. 2x2 is z2. 2 times 1 equal 1. Right? So if z2 is 1, 2 times what gives you 1? 2 times half. Or you could rewrite this as x2 equals z2 over 2. Right? So if z2 is 1, x2 is half. So this would be half. My, jump all the way back out here. Can't bother with this, you know. Where were we again? Right, all the way here. So here we have x2 being half. So working on this one here, this is going to be negative half minus 3y2 equals negative 3z2. But z2 is 1, so it's negative 3. So we can find y2. So add half to both sides. Negative 3y2 equals negative 3 plus half. So what is negative 3 plus half? It's going to be negative 2 and a half, which is negative 5 over 2. So negative 3y2 equal negative 5 over 2. So y2 would be negative 5 over 2 times, divided by negative 5 over 2 divided by negative 3. But it would be the same as negative 5 over 2 times negative 1/3. So times negative 1/3. Negative cancel negative. This would be 5 over 2, 3, 6. 5 over 6. Alright? That would be the eigenvectors. But we don't want any fraction. Let's put everything as integers. So let's multiply everything by 6. 1 times 6 is 6. 5 over 6 by 6 is going to be 5. Half by 6 is 3. So it's 3, 5, 6. So we have 3 eigenvectors here. We have 3, 5, 6 along with these. So we have these two eigenvectors, 1, 0, 3, negative 1, 0, 3. That's what happened when when lambda equals negative 2, and then when lambda equals 1, then the eigenvector we have is 3, 5, 6. Alright? So lambda equals negative 2, we get these, and lambda equals 1, we get this one. Right? So we could say lambda equals negative 2, lambda equals 1. When lambda equals negative 2, we have these eigenvectors here. When lambda equals 1, we have this eigenvector here. So I have a total of 3 eigenvectors.